Hello students, this is Mr. McAllen, and we are going to be working on doing some more polynomial division. So what we're going to work on with this one problem, it's going to be a pretty quick video, but we want to basically talk about if we take a second order polynomial and we divide it by some linear terms. So I'm going to first show the first one using long division, and then I'm going to show it with synthetic division, and then I'm going to talk about what the remainder theorem says. So let's get into this. So the first problem is by doing long division. I'm going to take x minus 2 and I'm going to put into that 3x squared plus 7x minus 20. This is a very inefficient way to do this problem, but again, it's stressing long division. So what we do in this case is, we're going to look and see what we multiply x minus 2 by to match up with the leading term, and that's going to be 3x. So I write down 3x squared minus 6x. In the earlier video, we talked about a much longer problem with long division. So remember, you have to subtract that term, the x's cancel, and we end up having 13x, and to bring down the negative 20. And now I want to multiply this by 13 so that I get a matching leading term, which is 13x, but now that's minus 26. So remember, this is not, I have to then subtract that term, and I'm going to end up getting a remainder of 6 from this. So basically, I could say that 3x plus squared plus 7x minus 20, when I divide it by x minus 2, that's going to equal what the quotient was, 3x plus 13 plus a remainder. Now I can't say plus 6 because that would make 19, and that's incorrect. It would be 6 over what the divisor was, which is x minus 2. So if we had no remainder, what would happen is this term would be gone, and then we would say x minus 2 is indeed a factor of the polynomial that we're dividing by. So a quicker way to check this out is to do synthetic division. So if you're doing 3x squared plus 7x minus 20, and you're going to divide it by x minus 2, what you do is you figure out what the root would be. So that would be a 2. You put down, you draw a line, and you work with a coefficient vector, which would be 3, 7, and 20. That would represent the leading terms or the coefficients of the polynomial. Your first move is to bring down the 3. And then you multiply by the 2, and you put 6 over here. And then you vertically add. So we have 13. And now I'm going to multiply 2 by the 13. And I'm going to get 26. Now I notice I made a mistake when I copied this down. That should be minus 20. And as a result, I get 6 here, but this tells me a lot of important information that was much quicker than doing long division. What it tells me is that my original polynomial, which was 3x squared plus 7x minus 20, when it gets divided by x minus 2, is equal to, this becomes a depressed polynomial by 1 degree. This becomes 3x plus 13. This is my remainder, so I got 6 over x minus 2. And this is a much more compact way to do a very complicated math project or process. And as a result, we like using synthetic division because it does our work for us much quicker. If I did find a root, or if this was a root value, my remainder would be 0. Let's take a look at another example from this problem. We're going to try dividing by x plus 1. And I could do that long division wise, but I really would rather stick with doing synthetic. So what I need to do is I need to figure out what that root would be. So the root, if this is indeed a factor, if x plus 1 is a factor, then x equals negative 1 is my root. And that's what I need to use in synthetic division. So I go back to the synthetic drawing board. I write down, I have 3, let me just look at the problem again. I had 3, 7, and negative 20 on top. And over here I had negative 1. Bring down my 3. It's very easy to do. Multiply by negative 1, I have negative 3, so now it's going to make 4 when I add it. I multiply by -1, and I get -4. And now I see that my remainder in this case is -24. So that wasn't a root either. Let's check for one more and see if I divide by x plus 4. So when I divide by x plus 4, I'm going to have my coefficients are going to be 3, 7, and -20 again from the earlier problem. I'm going to put, I think I said -4. Let's just double check. Yep, so that would be -4. Remember, you look at this term, you set it equal to 0, because that's a linear, that's a factor. We're hoping it's a factor. We get x equals -4, so that's what I'm going to use in synthetic division. So then I bring the 3 down, I multiply, I get -12. From this, I'm going to get -5. When I multiply by this, I'm going to have 20. All right, I found a factor, I found a root value, or a 0, and I know that that term from before was a factor. So I could say that 3x squared plus 7x minus 20, all divided by x plus 4, is equal to the depressed polynomial 3x minus 5. No remainder. So what else is really, really neat about synthetic division? Well, I have one other thing to show you about this. So what this tells me is this. Let's say that f of x is that polynomial 3x squared plus 7x plus 20, the one we were dividing. So now let's say that I was supposing that this was a root. So if x equals 2 was a root, my function would equal 0. But what happened was when I used 2 to check for a root, I got a remainder of 6. So check this out. It's no coincidence. If I plug in f of 2 and I put in 3 times 2 squared plus 7 times 2, remember this is minus 20, I made a typo again. No, not a typo, I wrote down the wrong thing. Right? When I do that math, I get 18. Oh, wrong math. 3 times 4 is 12 plus 14 minus 20. This is going to equal 6. And there's absolutely no coincidence that f of 2 equals 6, which is the same thing as a remainder. In fact, this is called the remainder theorem. Remainder theorem basically says if you plug 2 into the function and it's not a root, it doesn't result in a 0 value, this would be the remainder that you would get through doing long division. Let's check it out one more time. I'm going to check it when I do f of, remember when I put -1 in, I had a remainder of -24. So let's check it out. I'm going to do f of -1. I'm going to put it into the same function. 3 times -1 squared plus 7 times -1 minus 20. Let's see what we get. So I have 3 minus 7 minus 20, and as a result I get -24. So again, when you plug in a value that's not a root value, the value you get is the actual remainder from the division. We're going to do more with this in class, but I just wanted to share that with you, just to introduce you to synthetic division if you didn't already know about it, and tell you about what those terms mean once you get the value at the end of the synthetic division. It's not just a waste of your time, it actually gives you some valuable information that we're going to use later on in the process of working with polynomials. I hope this video has helped, and I look forward to hearing your comments.